Okay, so for this review, I'm going to just remind you of a few things that you have seen in Khan Academy, or should have seen. But the first being the number I. So this imaginary number I, when you multiply I together, you get an I squared, and that gives you negative 1. So that's the key idea right there. I squared is equal to negative 1. So when we're simplifying things, they're pretty simple. You just multiply things when they need to multiply, and then combine like terms when you need to combine like terms. So when we're multiplying this first one here, 8i times 3i, we'd have 24i squared. Now before you go and distribute that into the next set of parentheses, the I squared is negative 1, so this is going to become negative 24. And then I would drop down the rest of it and simply distribute that negative 24, and then I have my answer. Okay, whenever you have an I squared, you get a negative 1. So one like number 3, you're going to distribute. The last term would give you an I squared. So that'd be what, negative 56 I squared. The I squared is going to turn that into a positive 56, and it's just a regular number now, and it would get combined with the negative 24 from the first two. So obviously I did not do everything there. You can finish the rest of it. Number 4 is a little bit of a trick to it. When you have a square, it means to multiply it by itself. Don't forget that. So you're going to multiply two parentheses there. Just rewrite it twice. So negative 6 plus 4i times negative 6 plus 4i, and then you're distributing just like number 3. Numbers 5 and 6 are even easier. There's a subtraction in between the parentheses, so you will not multiply anything. You're not going to distribute. You're just going to combine like terms. One way to think about it is that negative will distribute in and change the signs of the second set of parentheses, and then you drop the first, and then combine like terms from there. Okay, so you'd have 6 minus 5 would be 1, negative 6i minus 6i would be negative 12i, and then you're done. So don't take it any farther than you need to. The other way to think about it is just to subtract each piece. So this is negative 8 minus 2. So negative 8 minus 2 would be negative 10. Then you'd have negative 4i minus I. Negative 4i minus I would be negative 5i. So there's a couple different ways of thinking about how to do that. And then factoring completely. Now the way Khan Academy showed you how to do it is a really good way. I'll show you another way that you can choose which way you like. There's a little organizer here that you just draw a little star. On the top you put A times C, on the bottom you put B, and on the bottom side you put A. But before doing that, check, can you factor out a common factor? Okay, you're always checking for a common factor. In this case, you can take out a k. Can't take out any numbers, but we can take out a k. I can't take a number because the first one's a 7. You can't divide 55 by 7, so you can't divide all. You can't do any of them. So we're going to have 7k squared because those exponents get reduced. 55k and then 42. And then here is where you're going to multiply the a times the c. So we're going to do 7 times 42. And so we're going to get 294 on top. And then the b number is 55, and the a is 7. So these two side empty spots need to multiply to get the top and add to get the bottom. So just like with the Khan Academy method, you're multiplying to get that and adding to get the other. So when you're looking for the numbers, you take the 294 or whatever's on top. I mean, if it's a smaller number, you can just think about the factors. But when it's a bigger number, just divide it by whatever you want to. You're kind of guessing and checking. And I always say to start small. So if you do 294 divided by 2, it's definitely not going to work, but it'll kind of show you the process. It's going to give you 147, but 147 plus 2 is not 55. So then you try another one, 294 divided by 3. If I divide it by 3, I get 98. So 98 plus 3 is not 55, but it's getting a lot closer. So you want to keep going bigger than 3. So do 294 and divide it by 6. I know 5 won't work, and I know 4 won't work. Sometimes you want to just skip ahead. And 6 gives you 49. So 6 plus 49 is going to be 55. So those are the numbers we're looking for. And then this side fractions here, you want to simplify them if they can. 6 over 7 does not simplify, but 49 over 7 does. And then you write your factors. So that common factor k that we brought out drops down, and then this 6 over 7 gives you 7k plus 6. And then the 7 over 1 gives you 1k plus 7. Okay, and then there it's factored. You're welcome to use the Khan Academy factoring method or use this method. Either way works great. Whichever way you go, you want to do a common factor out first. So if you divide them all by the biggest number that you can or the letter that you can, like in number 7. So in number 8, 28, 108, and 160, I know they can all be divided by 4, and I'm guessing that it's not going to divide by 28. But check and see, no it doesn't, so then divide them all by 4. That's your common factor. So the greatest common factor, you always want to pull that out first, and the result is going inside the parentheses. So 108 divided by 4 is going to be 27. Keep it negative. And then 160 divided by 4, negative 40. So then once you got 27 there. Once you got it to there, then you jump over to the star or the Khan Academy method. So to remind you a little bit about solving quadratic equations, you can either factor and then solve, or use the quadratic formula. Either way is a good way to go. The quadratic formula that I'm writing here will always work. Okay, factoring will work a lot of the time, but quadratic formula will always work. So if you're uncomfortable with factoring or just like the quadratic formula better, use it. It'll always work. It's fine. But either way you go, make sure it's equal to 0 first. Once it's equal to 0, then you have your A, B, and C. And then you can plug them into the quadratic formula or do the factoring. So yeah, I'll show you this one with factoring. It's going to be a tricky factoring one. So when it's a trickier factoring one, I might just do quadratic formula. So I multiplied A times C to go on the top, and then the B is 50, so it goes on the bottom. 7 is the A, so it goes on the sides. So when the top number is negative, I know that the signs are going to be opposite. One's positive, one's negative. So that tells me that the two numbers will subtract to get 50. So that's what I'm thinking in my head when I take 336 divided by, I'm just going to pick 6. I don't know if it's going to work. Oh, look at that, it did. So if I divide 336 by 6, I get 56. So 6 times 56. So then the question is which one's negative? Well, to get a positive 50, I want the 6 to be a negative and the 56 to be the positive. Once I get to there, I'm going to simplify this side fraction down to 8 over 1. And the other one doesn't really need to be rewritten, but there it is. Then when you write your factors, you're going to have 1x plus 8 and 7x minus 6. And then this is the zero product property where you set each of those equal to 0 and solve. And they're really easy to solve equations. Just subtract 8, x is negative 8, add 6, and divide by 7. X is 6 over 7. Alright, so that's the solving by factoring, and you're welcome to use the quadratic formula again. But before you do that, make sure you move things over to make them equal 0. So this would be 21x squared plus 65x plus 24 equals 0. Now I can solve it. So I could do quadratic formula or factoring. Now this one, so I'm looking for a common factor to make things easier, but I don't think, yeah, there is no common factor. So you're going to have to deal with it and multiply a times c, you're going to get a large number, but if you don't want to do that, do the quadratic formula. And that's all we've got. So if there's something missing, like 18, you're going to move that over and you're going to have a missing piece. You just need to realize which one's missing. In this case, the b is the missing one. So your b is going to equal 0 when you go to do either the quadratic formula or the factoring. Now I believe that these last two, I believe that neither of them are actually factorable. Yeah, so if I do a common factor here of 4, it's going to give me r squared plus 3. And yeah, this is not going to be factorable. So if you run into something that's not factorable, so I put the 3 on top, a is 1 now, and the b is 0. So I can't multiply to get 3 and add to get 0. Because the only way you're going to get 0 is if one's negative and one's positive, and they're the exact same number, right? 10 minus 10 is 0. But 3 is not a perfect square, so factoring is not going to work. So if factoring doesn't work, then your only option is the quadratic formula. So these last two use the quadratic formula. Okay, so if you've got any questions, make sure you ask. Test will be next Wednesday, so make sure you're ready for that.